guys, how you going? Got a monster of a job this week. I'll say this week it's going to take absolutely weeks to complete this job. I'll just be working sort of 8-hour days, not including breaks and things. So yeah, many hours cutting and welding ahead of me. So what you're looking at is I'm not sure of its exact name, but it contains the ram and the cutting blade of a large guillotine scrap metal shear. So on the top there's a hydraulic ram is fitted, exerting forces of probably 1,000–1,500 tons, maybe more, and it has completely cracked the frame to pieces, unfortunately due to not servicing the blades. The blades are left in till they become worn to the point of being very large rounded edges with no cutting qualities whatsoever. So instead of cutting the metal, it folds the metal over the edges, and shearing force on the blade is then transformed into a separation force, which loads this structure and gives incredible forces in directions that it was never designed to sustain those forces. So if you imagine a pair of scissors with blunt blades, and you cut the paper and the paper just folds between the blades rather than cutting. So this is exactly the same theory with this machine. So it tries to separate the blade instead of cutting the metal, and basically bursts all the superstructure of it. So it's basically a guillotine, as I say. If you imagine an old medieval tool that was used for beheading prisoners, where they pull the rope and the blade comes down and chops their head off. Well, this machine works on exactly the same principle with an extremely large hydraulic ram. So to give you an idea of what we're dealing with, this plate here is 120 millimeters. What's that? I think that's about 5 inches for our American friends, and it's completely broken right through. So that plate will need replaced, and in order to replace that plate, this large, I think it's 65mm plate, will have to be removed. So 65 and 120mm plate, ludicrous quantities of cutting, gouging, burning, grinding and welding. Just another day in the life of our engineering shop, where we're crazy enough to take on jobs that others would simply declare unfeasible. We will bring it back from the dead. So yeah, that's one of many extremely bad cracks. Another one is here. Right up through. And that's inside this box cover, which will all have to be removed. On the main piece of structure at the top there is also broken. So that will also be repaired, those side frames. You get a better idea here of the guillotine style structure. That's where the hydraulic ram is mounted. That's where the prisoner's head goes, and where the blade slides down, and that's where the material slides out this little chute on the bottom. So yeah, extreme forces to break 120mm plate. So yeah, I know not many of you guys will be able to identify with this piece of equipment and find it interesting, but lots of extremely heavy metal crack repair. So hopefully some of you guys find it interesting. This will be weeks and weeks of work condensed into short video, hopefully. I'll try and keep it short and sweet, with some time lapse, and yeah, lots and lots of wire, a bit like my large crusher video if you've seen it. I imagine there'll be lots of materials used in this. So yeah guys, stay tuned. So key to cutting such thick material is an extremely large burning nozzle. I'm not very knowledgeable with burning nozzle sizes, but roughly speaking, the thicker the plate, the larger the nozzle. So my nozzle's a bit, it's got some blowback and spatter on it. So we'll have to clean it with this little nozzle cleaner kit. And on the nozzle cleaning kit you can actually see the jet sizes are wrote on it. The only problem with large cutting nozzle is it uses a large quantity of oxygen, so cutting thick material is expensive, takes lots of gas. So we're already into our first bottle change, and I'm sure it will not be the last on this project. So yeah, we'll screw the regulator off the bottle, wheel the new one in, and get back to cutting. So that's the center rib cut all the way around. Sorry I don't have any footage of performing the actual cutting. I'm working here on my own. I'll try and get a friend to get a shot of the cutting jet in action. But yeah, that's it, all cut at the moment anyway, so it could be tricky to get it completely freed, but I'll get a sledgehammer, give it a beat. Often when it's coming out of a slot, because it's rough, it can stick, but I'll hit it with a hammer and see. You know it's hot work, guys, when the steam's coming off your hands. My phone's so hot I can hardly hold it. I'm surprised it's working. But so far we've got all this shit hacked off, and it's just the last bit of the table. So we'll set you up for a little shot. The gas bottle, he's all frosty, all ice. It's using so much oxygen. So that's it all cut off. Yeah, it's messy as hell, but don't forget we're not putting something together, we're taking it apart. So the name of the game is get it off ASAP. So we're not worrying about finish, we're just worrying about minimum cuts, maximum removal. So that's it all hacked off to hell. Next stage will be gouging all the welds off this broken 5-inch 120mm plate and taking it off. I reckon there could be a couple of days gouging at that, trying to get it released. So that'll be the next stage. So yeah, stay tuned for the next day's fun. So finally, after an epic battle, I'm making a bit of progress. I got the 5-inch plate out. You can clearly see the break in it and the reason why we're replacing it. Initially it looked like a simple job to gouge around the outside along the bottom, but of course it's never that simple when reverse disassembling a machine. The main problem being that the block had a chamfer here and this weld on the blind side of the block, which meant I had to gouge full thickness down the side of the plate to get the suspected blind weld, which wasn't even on the engineering drawings, which just goes to show you that different things can happen in the factory during assembly. So that allowed me to get this blind weld out of the back. You can see where the last bit broke off. Unfortunately, that means I also have to do this side, gouge this out at a 30 or 45 degree angle, full 120mm to access. If you imagine this weld welded onto that, full height. So I've got a couple of hours gouging there to get the last half of this 120mm plate out. Yeah, she's definitely giving me a battle, and she's definitely keeping me warm on this cold day. Sweatisflying.com. So yeah, I'll get the gouger fired up and get back at it. Good morning, guys. Got the shear or guillotine head off the bench down on his back, just to make a little bit easier for me to reach some of the cracks. As you can see, we got the side cut out of it, giving access to the massive cracks on the side plate. We have them provisionally gouged out. started gouging out some of the cracks on the back plate. And the main structural cracks here, you can see these are the main structural members that take all of the shear load on a tension basis, and as you can see, they're both badly cracked both sides. So I'll be welding these up and putting plates on the outside along this edge to try and tie that edge together. Can't put any plates on the inside because that's where the shear blade slides up and down, so just have to put some on the outside. So yeah, that's the progress so far. Got all the plates, the 5-inch plate cut out of the rear, and the new one has been cut out on the machine already. There it is there, cut in half. And that's some of the slag that just came out of the job. Real serious quantity of gouging rods and slag. So yeah, I'll just finish off some gouging, and then I have to start grinding all the gouging snotters, as I call them. Grind them off, and then we'll start the welding back together process. That's all the topside cracks gouged out, and all the shit knocked off with the grinder. So we'll get the welder fired up here now, and start filling back up. A lot of fatigue cracks. Pain in the ass, particularly when they're close together like that. Exacerbated whenever there's two plates put together. Essentially have a double crack to deal with. This one here is broken and bent up, so I'll have to see about trying to press that down into place before welding it. So yeah, the welding starts now. So here we are in the pit of hell. I've just finished welding the bottom two cracks and side seams where they had split and cracked also. So that's the lower intersection completed. That will have to go to the milling machine to get refaced, I would imagine, and all of those holes sorted out. But that leaves us now to move on further up to these cracks. So that's where I have them gouged out, ready for full penetration weld. And then when I turn it over, I'll back gouge the root and weld it also, giving a completely solid weld. I'll probably turn it onto its side to do the corner welds. You can see where they're gouged out there in the prep. So yeah, still shitloads left to do. So yeah, I'll keep you posted, and looking forward to getting it off its bloody back. I'm fed up the sight of it already. Completely destroyed one pair of overalls in just over a week. They're fully certified fireproof overalls, and they are shagged. 1 week old, or 1 week's worth of gouging and welding. They're 2 weeks old. Never even seen their first weld. Seen their first wash, I should say. Yeah, I've been welding too long. So yeah, these buggers here, carbon air arc gouging rod, and that's what gouges the metal out to give us this prep right down the crack. And awful thing to use. They create lots of highly toxic fumes. Super fine carbon powder that gets right in the bottom of your lungs, the smallest particle size possible. And an ex-shipyard guy told me there's no such thing as an old gouger, as they're all dead. So just getting these strengthening plates tacked on to the sides here. The hydraulic ram press force has broken right at the corner, and can't put anything on the inside because that's where the guillotine blade retracts. So in order to try and strengthen up these side ties, we put on this large strengthening plate. Nice straightforward addition, just welded on. Should greatly increase the strength of the cross member onto the side members. Don't have much other choice, as I say, internally, so this is the only option we have left on the outside. It should be more than effective. And this will tie this onto this, giving a really strong joint. So yeah, let's get her on. So that's the two strengthening plates welded on, just on the solid wire. Don't like going too close to my weld. It just wouldn't be Instagram standards for you weld perverts, but good fucking gorilla weld, nice and strong. That's the main thing. So yeah, that's the two strengthened side plates on, and we have welded up the corner cracks also. We were trying to decide the plan for this cross member, and we've decided it's worn too thin and too far gone, so we're going to cut it out and replace it with a new section. It's going to be a pain in the ass to cut out because we're cutting into a blank wall, so we'll probably have to gouge it out. So that's going to be fun. We have the cracks down the side and down the bottom done. Just the two large cracks at the top to do, and that will be the internal work finished. So yeah, I'll check back in a bit when we get that done. So I'll have to gouge this bottom plate off and gouge a weld prep into it. So I'll take the rest of the day at least. So that's it gouged out with the air arc gouger. Just all the shit to chisel off with the air chisel. And we'll do a test fit, see is there enough prep. Air arc gouger, absolutely horrendous temperatures. Legs are absolutely painful heat there. I know I can get leathers and stuff, but yeah, it's the usual story. You just fight the pain and then complain about it. So friggin' legs roasted, hands roasted, molten steel lying on the floor like an iron foundry, and big glowing heaps, and absolutely roasting. But got a lot of shit left over to clean off, so we'll clean that off with the air chisel. See what it looks like. So that's the replacement plate tacked into place after gouging a prep on, removing the old one. So just lots of welding now, so we'll see you in a couple of hours. So that's the new center cross member, all welded in. We're going to turn it on to the side now and fill in the big crack on the sides. So yeah, let's get her chained up the crane and turned over. So that's it turned over. Going to fill up this large crack here. And also the crack on the top here. And we'll back gouge this root and also that one and weld those up solid. And that'll be the main structural cracks, welded on both sides with fully back gouged roots, taking it back to almost as strong as original. So yeah, we'll get them gouges out and weld it up. So that's that monster on the inside welded up. Just have the one on the top to do. So now I'm completing the cracks on the bottom, which were gouged out the other day. It is welded. Put a little brace across the thin piece below the hole and clean the edges of the box, ready to reinstall the box cover. It'll then be turned over and the back of that crack will be back gouged. The bottom here has been prepped and a lot of grinding, cleaning up done. So yeah, that's where we're at today, is closing up this box. Chilly morning, so we'll get the big blow nail going, get some preheat into it. Takes an absolute age to do these jobs with preheat, but a necessary part of the process, unfortunately. So that's the lid refitted. I put it back in plate, all of the joints welded through on them. Refitted the hose routing supports. So yeah, it's another big one ticked off the list. Not sure what's next. Probably lay it down on its flat and do this one here. So we'll do this crack here on the flat, these here, and also back gouge the weld that I have just completed on the inside. You know you must be doing something right when you get word that they're sending one of these things from bloody Australia to the UK to get repaired. So anyway, finished back gouge in the crack. Finished back gouge in the crack. There's nothing satisfying as gouging out the back of the root weld and it coming up absolutely pristine, clean. So we'll weld the back of that weld, and that's that join completed. Then we'll be ready to start and set the blocks, the new 5-inch block, set it back in. That sounds like the 150-ton press maxed out in the other end of the workshop. We'll just have a look. So yeah, now we'll fill up this crack, fill up these ones. A little crack on the corner here. You can still see the remnants of the crack in the bottom of the gouge. So I'm going to go halfway from this side, and halfway from the other side. A really good thing about the gouger is it seems to cause a magnetic field across the cracks, almost like an NDT magnetic weld crack test. And then when you grind, the little flakes of grinding dust all stick to the polarized edges of the crack, highlighting it. So just a funny little benefit to the gouger. You can see the remnants, scars of where the 5-inch plate was removed and the 60mm top plate, and all of those will be filled with the weld that will hold the new block in, and the same on this side. So yeah, I just wanted to show you the back of the root, show you how clean it is. Super satisfying. Super satisfying. So we're just getting ready to start to assemble the heavy plate back into the body.
and part of the job that I despise. Our old friend, the noisy fucking bloody 9-inch grinder. The plate's got a skin of rust or oxidization, if you want to talk fancy, and unfortunately that is not compatible with a good weld, so that means lots and lots of 9-inch grinding, lots of noise and lots of dust. So yeah, we get this little layer of rust all ground off, and then with a good preheat she'll be as strong as a clean piece of steel, because essentially once it's grinded it's a clean piece of steel. So after a test fit, unfortunately it's a little snug and can't quite hammer it into place. Sometimes just depending the settings of the profiler, it can come out a millimeter oversized, which is better of course than being undersized, because you can't put it back on but you can always cut it off. So at the moment I'm faced with having to trim a minuscule amount off this material. I think it's 60 millimeters. So we'll get the oxyacetylene fired up and see what we can do. So yeah, that cut not too bad. Took me halfway down the cut before I got into the flow, but that is cut bloody beautiful. I'm very pleased with that for a freehand cut with a massive nozzle. Yeah, it's not Instagram perfect, and you guys cutting heavy plate all day, I'm sure you could do a lot better, but it'll get me out of the hole. This cross member doesn't require a tight fit for structural integrity, as it's all the weld that's carrying the load. So we'll give it a grind and slide it in, and it should be fine. So yeah, I'm very pleased with that finish. Just manually, I could have went and got the quickie, the little gas cutter that runs on the tracks, and done it with it, but this will be more than adequate for what's required. So a quick kiss with the grinder and that'll be it. So yeah, I'm bloody delighted with that. It's turned out absolutely beautiful for a freehand cut. Very happy with that. So yeah, we'll try it in. Free tip: if you're working on a concrete floor and you're burning and creating a lot of slag, you're going to want to put something down to catch that, because if it lands on the concrete floor it will make it burst. You can see the damage there from other jobs. So yeah, you want to catch your slag and not let it contact the concrete, as it'll make the concrete explode and leave a big pock mark on your nice floor. So yeah, make sure you catch the slag. So yeah, let's get this test fitted into place. See what it's like.
The pain is real, the struggle is real. So yeah, that's just how it goes. We need a little bit more of it. So of course now it's jammed in there, so I have to chain it up, rip it out, set it back down, trim a little bit more off, and repeat. But yeah, you win some, you lose some, but better to have it just the right size rather than too loose. I'd rather take 2 cuts at it, get it right, than 1 cut and it'd be too loose. So yeah, we'll try and take 2 cuts and not make it too loose. So yeah, let's get into it.
So the saga continues. So pardon me, after 2 cuts, a cut each side, lots and lots and lots and lots of grinding, still just couldn't get it to wedge in. So I had a nice little brainwave. I said to myself, I'll heat this plate, and because it's so long, there should be massive expansion over that area. So got the propane torch and heated it up, and just like a thing of beauty, it just crept right down into its final position, just as nice as you could ever imagine. And then I had a closer look. We have a gap along here and along here. So not due to my heating, because it was heated evenly all over. So right into it this morning, just getting the big center spine rib wedged into place. This bottom plate's a little bit warped and bent in, so unfortunately that means a bit of dogging. Aussies probably wouldn't know what dogging is, but dogging with a scotch, I believe this little invention's called. I don't know where that came from, but anyway, yeah, so got it all put into place yesterday, and the gussets tacked into place, and one side partially welded. So we're well on the way back together. The side piece completely closed up, so starting to see some light at the end of the tunnel. So we'll just get a stack of preheat going here this morning, get all this steel up to 200 degrees ish if we can. Quite a lot of metal there, it'll take an awful lot of heating. Very gas intensive, these heavy plate jobs, and it takes quite a lot of time as well, but need to preheat everything in order to stop it warping, creating stress within the finished weld, and excluding as much hydrogen as possible. So yeah, let's get her heated and get in there. Get up. That's all the welds done on this position. I was just checking a few measurements to see if the spacing was correct, and a little mishap with this gusset here. You have to weld both sides pretty much at the same time, because depending on what side you weld on dictates what side that will pull to. And I'd welded a little bit too much on the right hand side before the left, and that meant that the top had pulled over and knocked the measurement out. So I'm just in the process of wedging it back into place. It's currently in the right place now with a stout wedge and the hammer. You can see where it broke the original tack. I've wedged it back into place where the original tack is, and I'll just weld across the top of that now and remove the wedge. That will be that one back in the correct spacing. So that's all the welds done on this position. Getting ready to turn it on to its side to do the rest. I'm turning the job as opposed to welding in position, because I'm using 1.2 mil solid steel wire. So rather than put flux core in and do it positionally, because I have other more awkward welds, I'll be turning the job anyway, so it suits better in this case to run the solid wire and turn the job to suit. So we're getting ready for another turn here now, and that will allow us to do all the welds that are currently on the vertical, but which will then be turned on the side, which will put them on the flat. So turn it over now and see what the next step is. So yeah, just a little quick sweep up. Absolutely mind-blowing, the quantity of material that comes off these jobs. What you're looking at is virtually a wheelbarrow's worth of sparks and dust and cuttings and grindings and grinding discs. Like about 10 grinding discs there and particles. Great stuff to breathe when it's airborne. So yeah, that's it on its side now. We see the front face again, which is starting to look a bit more respectable. On the rear is the lid that was put on, and now all of these welds that we're now going to do. So yeah, stay tuned. So that's all the welding completed of the main table, where the bottom blade, the fixed blade, is bolted onto. All the welding is complete. The next stop will be the machine shop. We'll load it up, take it round, and there has to be a row of holes drilled right through that 120mm plate. So we'll go around there and get some footage of the massive drilling machine in action. So stay tuned, guys. Very impressive machine. So we're catching up with it after many weeks. Brendan here, the customer's been working on it flat out, and this is a test fit of the what do you call that section? Clamp. So this is a test run of the clamp in the slides. So all the slideways have obviously been machined and replaced, and that block has been welded up and machined. So that holds down the scrap, and then the shear blade cuts it. So as it's called, the clamps it down. This is obviously normally powered by a hydraulic ram, which is mounted on the block above. Brendan has carried out a lot of work since I was last at it. He has replaced the slides on the inside, and he has done a lot of hard facing building up on the bottom. So it's really starting to take shape now. He's also replaced these wing sections on the outside. A lot of beautiful vertical welding, very nice indeed. He's done a really tasty job on that. So Brendan's been working hard all weekend, and he's got the blade in, fitted, the guides and slides, and that's pretty much it. Ready to leave the workshop, go on to site, be commissioned. I think Brendan from Nexus Plant is hoping to grab me a couple of clips of them installing it and commissioning it and running it on a few cycles of operation. So I'll put those in at the end of the video. So yeah, we'll have a quick look around it. So as I said right at the start of the video, that's your Frenchman's guillotine. Colossal amount of work done to it. All seating faces remachined, and a lot of hard facing. All Brendan's lovely hard facing work. So as you can imagine, with a 500-ton ram behind it, it's going to cut pretty much anything that fits through this hole. No wonder it cracked down these corners. I put this big plate on to strengthen it. So yeah guys, stay tuned for the video of it working.
went too fast.